Scientific notation. Most of you are pretty familiar with scientific notation, so hopefully this will just be a great big review. It's just a form that we use to write very large or very small numbers so that you don't have to write all the zeros down. It uses powers of 10 to shorten those numbers. So a decimal point is between the, is put behind the first non-zero number, and then the power of 10 number is the number of times that the decimal place gets moved. A number that begins as very large has a positive exponent, and a number that begins as a very small number has a negative exponent. So if we look here, I'd like you to pause the video and write these into scientific notation to see how much you remember. Okay, so as we look here, we've got a large number to begin with. So here we're going to put one number to the left of the decimal. So right here we put our 1 and then we put our decimal. Now in this case we have to keep every single one of these numbers because they're all significant. So we would write this number just moving the decimal place over, and then we would count how many decimal places did I move. 1, 2, 3, 4. So our exponent becomes a 4. In this case, we're starting with a very small number, so again, we only want one number to the left of the decimal place, so it moves here between the 6 and the 5. Again, we keep all of these numbers here because they're significant. So now we moved our place from here, 1, 2, 3, 4, 5 spots. Because it was a small number, it's a negative exponent. Here, again, we have to keep all of our digits because they're all significant here. We want our digit to end up here, our decimal to end up here between the 1 and the 2. So there's one number to the left, and we count how many we moved. 1, 2. So our exponent becomes a 2. Here, our significant figures are these last 4 digits. So again, we keep all of those. We want one number to the left of the decimal, so it ends up here between the 7 and the 5, and we move 1, 2, 3, 4, 5, 6, 7 spots. So we have a negative 7 exponent. And again, this shows the answers to what we just did. So a positive power of 10 means that you make the number bigger, and a negative power means you need to make the number smaller. You move the decimal place to make the number bigger or smaller, and that's your power of 10. That's how you read a scientific notation. Now I'm going to have you pause the video and write these into long form numbers. Okay, so here again, positive number, so we're going to be moving our decimal place to the right, making a bigger number. So here we would move it 1, 2, we'd have to move it 2 more, so that's where our 2 zeros come into play. Here we would just have to move it 2, so it goes between the 7 and the 5, again making the number larger. Here we have a negative exponent, so we're going to be moving our decimal to the left, so we're going to be making our number smaller. We move it one place here, and then we have to add 4 zeros. Okay, so we've got our decimal, 1, 2, 3, 4 zeros, and then our 8755. And then last but not least, here again we're making a smaller number, so we're going to move to the left. We move it one spot, and then we add our 2 zeros after the decimal place. Okay, it's more than just shorthand. It's a great way to write significant digits. Okay, so if you're not sure how many significant digits you have, scientific notation is a great way to do it. So if you're not sure here how many you have, you can move your decimal over so there's only one spot to the left, and then you would know all these have to stay significant. If you have a point here, okay, and you're not sure, you would move over here. You have to keep all those numbers in your scientific notation. Here, all you would have to have is 1.2. Okay, so here you've got 3 significant figures. Here you only had 2. Okay, so this is a great way to change numbers. Again, remember though that 120 is not the same as 120,000. Okay, so just because there's significant doesn't mean that you drop everything off. Here we've got 120,000. Only these two numbers are significant. Here we've got 1.20 times 10 to the 5th. Now we have 3 significant figures, but this is still the same number. We just have more digits that were measured. Okay. So write the following numbers in scientific notation. So pause your video, write them out, and then check your answers. Okay, so here We only want 3 significant digits. We have to take the first 3 numbers. Okay, so we would have 1.20. And we would be times to the 5th because we have to move 1, 2, 3, 4, 5 spots. This number we only want 2 significant digits, so we would have to have the 2 and the 3. So it'd be 2.3, and we'd be moving the decimal place 1, 2, 3, 4 spots. So it's a negative 4th exponent. Here we want 4 significant figures. Okay, so we would be taking our number and moving our decimal and moving it 1, 2, 3, 4 spots. The 5 is going to have to round up to a 6 because we only have 4 significant figures instead of 5. And here we want 2 significant figures, so we're going to keep both of these, and then we move 1, 2, 3, 4, 5, 6, 7. So to the negative 7th. Okay, so again, we're moving the decimal to the first number that's not 0, so there's only one number to the left of the decimal place. Start counting your significant digits from that first non-zero number. So that's what we did right here, 1, 2. And then round when you have an unwanted number of significant figures. So here we didn't want this 6, so we have to round our 5 up. Large numbers are positive exponents, tiny numbers are negative exponents. So again, let's try one more time. Pause your video. Here you're writing with a certain number of significant digits. Here you're writing them out in long form. So pause, write your answers, and then check. And here are your answers this time.